Morning, everybody. David Shapiro here with a video. The topic of this video is quite simply when AGI. Simple question, but the underlying answer is a little bit less straightforward, and that is we're going to talk about exponential growth. Well, before we get started, we have to talk about what even is AGI. The answer is quite simple. No one agrees. When you say AGI, it is latent with assumptions and implications, and there are people that think AGI has to be a super intelligent Skynet that can control everything. There are people that think AGI has to be embodied, that it has to be in a robotic form like you and me. So there's no one definition. There's plenty of assumptions. One definition that gets thrown around is that an AGI is a machine that is capable of any intellectual activity of any human. But that's not general intelligence, that's super intelligence, because if you have one machine that can do anything that 8 billion different people can do, excuse me, that's super intelligence, sorry. Another question, is it autonomous or is it reactive only? This is another thing that people like. If a machine just sits there and waits for a human to use it, can that even be qualified as AGI? Because isn't part of general intelligence the ability to create it and follow its own goals? So to me, autonomy is part of it, but people are not even talking about autonomous machines. Another thing that a lot of people assume is spontaneous learning. And so for humans, learning is completely automatic. Yes, you can engage in behaviors which increase learning, like you can choose to go to school or you can choose to read a book, but you don't even need to do that because learning is part of our hardware. It is part of our intrinsic underlying hardware. And so many people think that AGI has to have spontaneous learning. I don't know that I agree with that. But again, there's no agreement on any of this stuff. And then other people say, well, it's not AGI until it's conscious. What even is consciousness? Consciousness is an intrinsically subjective experience, so how do you measure a subjective experience for something else? You can't. From a neuroscience perspective, consciousness is basically whether or not you're awake. Or there's a few other criteria, but it's mostly subjective, so it's very difficult to measure. Then the tongue-in-cheek joke is, AGI is whatever machines can't do yet, which there will always be something that humans do differently or better or whatever from machines. And if there is a future where there is literally nothing that a human can do that a machine can't also do better, well, then we're in for a different type of existence. Personally, because of all this, AGI is a useless term. I prefer ACOG. So fans of my channel for a while will know that if you go back into my videos, what I focus on is artificial cognition. How do we approximate cognition, which is general purpose thought, and then it's just a matter of measuring how intelligent it is. And of course, even intelligence is not a single metric. There are many, many kinds of intelligence that are very difficult to measure because, again, it comes down to definitions. So with all that said, who cares? Like, AGI is an arbitrary goalpost that really isn't helpful and doesn't really mean anything, but the world is moving fast. So let's move on from the idea of AGI. But let's stick with that idea of human level of intelligence. When will we have machines that are human level of intelligence? Let's look at some thermodynamics first. So the human body uses roughly 100 watts of juice. And the brain uses roughly 20% of our total oxygen consumption. Therefore, you can estimate that the brain uses about 20 watts of energy. That's not much, right? That's less than, or actually that's more, it's a little bit more than the light that's behind my camera. But it's roughly a 50th of the computer that I'm recording this on, right? So our brains are really efficient. So that's the energetic part. But then how many flops, how many floating point operations per second does the human brain do, or how much would it take to approximate the human brain? Obviously, our brains are massively parallel, Each neuron is actually pretty slow. They operate at around 1,000 kilohertz, or 1 kilohertz. Right. Our neurons operate at about 1 kilohertz. Sorry, 1,000 hertz. Whereas CPUs and computers operate in the gigahertz range, but they're much smaller. So by having a diffuse parallel network, our brains technically operate much faster. But we'll get into that more details about why this is a bad analogy. But one thing I wanted to point out is that estimates about the flops of the human brain goes up every time we invent new computers. If you go back, I think there's an article in Wired when Deep Blue came out, and it's like everyone's like, Deep Blue is as powerful as a human brain, and it was like in the petaflops or gigaflops range. And then the gigaflops computers came out, and then the petaflops and teraflops and exaflops, and every time we come up with a new computer, we're like, this is as powerful as a human brain. Same trend for 25 years. So either our brains have become exponentially more powerful over the last 25 years, or we don't have the first freaking clue about how powerful our brains actually are. So presently, we think our brains are exascale computers, but it could be beyond that. We could have Yoda-scale computers in our head, which would be cool because they're only 3 pounds and use 20 watts of power. Nature do be crazy like that. So by comparison, an RTX 3090 weighs about 4.5 pounds. So our brains weigh less than a graphics card, and yet are more powerful than the most powerful supercomputers we have today. So it's safe to assume that there are, just from a pure entropic, like physics level of looking at it, that there are things that our brains can do that other machines cannot do yet, just by sheer virtue of efficiency. Now, that being said, brains are not computers, with some nuance, a lot of nuance. So let's look at the obvious differences. First, different architecture. We don't have a CPU and memory register that are separate. It's actually the same. One of the ways that your brain maintains its memory register is through 7 hertz pulses through the brain. And so it's actually kind of a memory state that is maintained along with the synaptic connections. So one of the things that is, there's quite a few things about the way that our brains hold memories and store memories and retrieve memories that are different. And when you look closer at neurons, you realize that memory and processing are the same. So the closest thing that we have in electronics is MEM resistors, which are not being used yet, not widely. So fundamentally different architecture. 2, fundamentally different substrate. Computers all run on silicon right now, and we run on organic, squishy, mostly cholesterol and fat-based materials as our substrate. It's pretty gross. Our brains are very, very squishy. Let's see. I've never touched a human brain. I did touch a pig brain when we were in middle school when we did dissections. Actually, I couldn't touch it. I was super grossed out. There's different signaling. So CPUs use electrons. Our brains use neurotransmitters. And no, they don't even remotely do the same thing. Neurotransmitters bind to specific sites. And there's ion channels and this, that, and the other, whereas electrons pass through gates, through metal oxide gates. And so you might say, okay, well, functionally, a neurotransmitter is kind of like a gate because it activates a thing and then the signal goes through. Ish. Okay, if you really want to break it down and like squint at it, sure. But then also, they use a fundamentally different kind of energy. Electromotive force, current, versus electrochemical energy. So when you take it all together, the brain, if it is a computer, is a fundamentally different kind of computer. Now, let's take a step back and just look at it from a raw physics perspective, from a first principles perspective. Brains and computers both process information. This is true. So, you say, okay, well, if it's a self-contained object that processes information, that's a computer. But if that's your definition of computer, then your entire body is a computer. because you process information, whether it's physical information or auditory information or all the processes going on inside of your body, then your body is also a computer. But your body can't do all the intellectual tasks on its own that we want computers to do. So does it count? Is it like, oh, well, that's not what I meant by computer? So the definition of it processes information is not necessarily a useful definition of computer, because if the definition of computer is any object or anything that processes information, then everything in the universe, this processes information. This processes information on a quantum level. It's processing the mechanical wave of my voice as it passes through it. It's processing the heat from my tea that's traversing it. But again, that's not useful to us in terms of intelligence. The entire universe is technically a computer from the perspective of physics. So again, depending on your scale, not really helpful. So for the sake of this argument, we're just going to say human brains are not actually computers. Even though technically, yes, they process information, but it's not the same. They just, the way that they process information is fundamentally different. Okay, so where are we? AGI is undefinable, but robots are real. So we could keep arguing over what AGI means and what the goals are, but it's this imaginary goalpost that keeps moving. So let's look at what is real. So what are some things that are actually happening? Private industry is going as fast as possible. Every single chip manufacturer and tech company out there is investing in AI, as well as every military and every government. They do not care what AGI is. There's a lot of money to be made, right? And where there's money to be made, the capitalists and the corporatists and the neoliberals are going to go in full force, right? Why do you think that crypto went really big? Is because there was money to be made, but it was the Wild West, and so there was no regulation, and so then you had the FTX collapse. So where there's a will, there's a way, and there is a heck of a lot of willpower in AI right now. The only entities even capable of slowing this down are governments and militaries, but they want it too. So this is going as fast as humanly possible. And I picked the Zoidberg meme because I can already hear some people in the comments saying, blah, 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 you're wrong about all this. And you're allowed to have that opinion, and you're also allowed to be wrong. The fact of the matter is, AI is dangerous and disruptive long before we achieve anything remotely called AGI. It doesn't matter. It's a useless term. AI can make our lives better now. It can also make our lives worse now. Look at how AI is being deployed for the social credit system and face tracking and even dumber things, basic machine learning, regression models predicting crime and overly targeting poor communities. The real problem is not the machine. The real problem is how we implement the machine, whether we implement it with benevolent intent and benevolent actual deployment, because there's always the law of unintended consequences, or malevolent deployment. Do we put this stuff in weapons of war, in tools of control and manipulation? By the way, this is why companies like Meta or Facebook have suddenly lost so much faith with the entire market share, is because everyone's like, actually, yeah, we don't like our attention and our emotions being gamified just for the sake of corporate profits. That is it. At least that's why I deleted my accounts. But who knows? So the point is, the problem exists today, right now, irrespective of AGI. All right, now I know you're probably glazing over because I promised when are we going to have AGI. I just needed to set the stage, so let's move on. So let's ignore the semantics and just let's look at the data. Let's look at the actual trends to figure out what's happening and when. So the first question is, since we're looking at data, I want you to keep in mind that there are two overarching kinds of graphs here. Now, everyone has assumed that exponential growth is the way because of things like Moore's law. But I want to call your attention to the possibility that until you get to the halfway point of a sigmoid curve, it looks exponential. And so over the last few years, we've heard like, oh, Moore's law is wearing out, and no one can agree on whether or not that's true. So if Moore's law is in fact wearing out, then maybe it was never an exponential growth curve. Maybe it was always a sigmoid growth curve. And so maybe we're actually here where it's starting to slow down, which if that's the case, then maybe things aren't happening as quickly as we thought. And maybe Ray Kurzweil was wrong and that the singularity is not near, but maybe it's actually like a couple centuries away. If we have diminishing returns, then maybe it is much further away than we thought. Or if we have compounding returns, it could be way closer than we think. So let's explore the data and see which way it goes. So first, I apologize for the blurriness of this. I couldn't find a larger, higher quality version. So this is the energy efficiency, the gigaflops per watt of AI technology. And so you look here, notice first the scale is logarithmic. This level is 10 gigaflops per watt, then 100, then 1,000. So each major rank goes up by a factor of 10. So this is logarithmic growth. This is the same thing. This is the same way that decibels are measured, and it's the same way, same as the Richter scale for earthquakes. So like, a 3 on the Richter scale is 10 times weaker than a 4, and a 5 is 10 times stronger than a 4. Same thing for decibels. So in this case, you see like, okay, in 2011, just 11 years ago, we were at 7 gigawatts per flops, or 7 G flops per watt. And then last year, well, I guess it's 2023 now, so 2 years ago, we were hovering at about 70. So it went up by a factor of 10. But then we also started doing a lower floating point, and we had new technologies. We had the tensor cores come out. And so then we had this quantum leap. So in the space of 10 years, we went from less than 10 gigaflops per watt to over 1,000. So in 10 years, we went up by a factor of 1,000. So what if 10 years from now, our AI chips are 1,000 times more efficient than they are today? That's insane to think about, because then it's not a matter of like, oh, can you run GPT-3 like on a big giant computer in the cloud? You could run GPT-3 on like an RTX 8090, right? Like when NVIDIA comes, just that, like that's just a couple generations. Like if NVIDIA comes out with a new generation every year and a half, so that's what? That's that would be six-ish generations. So we're on the 4090 right now, right? So then you go to like the 190 or the 9090 or whatever, right? So then like it's conceivable that you could run these language models on a home GPU within a few years, within a decade. That's pretty crazy. It's actually probably much less than that, because I think I did the math, and it would take about 90 mid-range GPUs today. So if we're going up by a factor of 10 or 1,000 if we're going up by a factor of 1,000 in 10 years, it'll be a lot less before we go up by a factor of 90. It'll be about half that. So the energy efficiency is going up. We're still a long ways off from the energy efficiency of our brain. Remember, we might have, currently we think we have exascale computers in our head that run on 20 watts of power and weigh 3 pounds. So we're a long ways off from that. But remember, the problem is today, if it's already dangerous at these levels of efficiency, how much more dangerous could it be at 1,000 times more efficient? Okay. So remember, we talked about the possibility of diminishing returns. So far on the hardware side, we don't have diminishing returns. We actually have accelerating returns as new technologies come out. So this is a point in the column for exponential growth, and maybe even hyperbolic growth or parabolic growth. Parabolic growth is the one that goes to infinite. If we have parabolic growth, I didn't even have a graph for that. Parabolic growth is even scarier. And if I'm saying that wrong, please let me know. I'm sure someone will in the comments. It's either hyperbolic or parabolic. One of those goes to infinite. The asymptote is like out there, and it's like, oh, at 10 years, you actually have infinite growth. So anyways, so there's one point in the possibility that things are actually accelerating, and the exponential growth might even be accelerating. So let's see if let's take a look at diminishing returns. For the last couple of years, the mantra has been scale is all you need. A buddy of mine at OpenAI, he messaged me. This is a couple of years ago. I haven't heard from him in like a year or two because because OpenAI has been very busy. But one of the last messages he told me is like, yeah, as far as we can tell, like all you need to do is just throw more data at it and more parameters, and it just becomes more intelligent. So we're going to see how far that takes us. And boy, howdy, has that worked so far. But here's the thing. Rumor has it that GPT-4 has been trained on most of the internet, like most of the data on the entire internet, which is just mind-blowing. So if we run out of data to train it on, what else is there? Like okay, that maybe one person had a hypothesis that that's why OpenAI trained Whisper, was so that they could get more data out of videos and podcasts. Because there's something like, what was it, like 90 years worth of videos on YouTube? That seems low. I think it's more than that. But the point is there are many, many years worth of content just on YouTube alone that could be transcribed with a tool like Whisper. Excuse me, I don't know why I get so congested in the mornings. So that's one possibility. Then you transcribe all the podcasts, right? And then you go multimodal. If you can describe what's happening on the videos and you describe it with language, you can get even more data, right? But point is, they're going to run out of data. So there might be diminishing returns. There's also some evidence that the larger the model, you actually don't necessarily get the returns for fully dense models. That once you get larger, that you probably have to go sparse. And so like once you get to the trillion parameter, it's almost certain that you need to have a sparse model. So my personal hypothesis is that GPT-4, it might be 1,000 times bigger than GPT-3, but it's probably a sparse model, which means not all of it is going to activate at any given moment. So maybe GPT-4 could be just as efficient to run as GPT-3, even though it could be hypothetically much, much larger. But this is all speculation. We should know by the end of 2023, hopefully within the next few months when GPT-4 comes out, and we can add another branch to this. But also take a look at this. This also scales logarithmically, right? So 1 billion, 10 billion, 100 billion, a trillion. So if this trend continues, then that's evidence for exponential. But you look at this where Megatron Turing kind of tapered off, right? So which way is the curve going? Is it gonna plateau, or is GPT-4 going to be up here and like, you know, a couple ranks up and just show that actually no, it's continuing to accelerate? So this is like, if they're running out of data, I don't know what they're going to do about that. Yeah, so this one's kind of a wash. We'll know more once GPT-4 comes out, or any other competitors, right? I know Google is working on their own competitors, and you know, Megatron. This is NVIDIA, so we'll see. Maybe Meta will come out with something, but I think the biggest players to look at are going to be OpenAI, NVIDIA, and actually those are the two biggest ones, and Google probably. So keep an eye on those three. So far, it looks like exponential hasn't given out, and it has been a durable trend for like a century. So this was posted on Reddit, and I believe it came from Source Time magazine. So I think this was an article talking about Ray Kurzweil's prediction for the singularity. So you look all the way back where we had electromechanical computers, and then relay-based computers and vacuum tubes and transistors, and then integrated circuits, and then who knows what comes out now. But the prediction is that computers will surpass human brain power this year. We'll see, you know. But that's the other thing with exponential growth, is that very small changes in that growth trajectory could mean that it happens 5 years from now, or it means that it might have already happened. Who knows? So, so far, it seems like there's a lot of evidence that exponential is still the name of the game, that it hasn't given out yet. So, if we are still growing exponentially, and we're going up by a factor of like 10 every 5 years, then and sometimes it feels like even less than that, then it's really difficult to predict what will be possible even just 2 years from now. I mean, and honestly, a year ago today, who would have predicted that ChatGPT would have had the impact that it did? So we'll see what happens. Now, uh, it's really difficult to wrap your head around exponential growth, and we'll get into a little bit more why. But the biggest thing that people have witnessed or experienced in their lifetime is the exponential growth of human population. Now, human population actually follows a sigmoid growth curve because we're approaching the carrying capacity of the planet, which means that competition for resources is making life harder. So, like, I don't care about government policies. The number one reason that housing prices are going up and food prices are going up, it's not inflation. It has to do with the thermodynamic limits of the entire planet. As we approach the carrying capacity of the planet, just by virtue of everything is more constrained, prices will go up, life gets harder, stress goes up, et cetera, et cetera. So overpopulation is actually, to me, a larger problem geopolitically than climate change, because climate change just makes that worse, the competition worse, but humans have survived climate change before. We've been through ice ages, right? That's not the problem. The problem is the additional stress that climate change puts on us at the same time that we're also approaching the carrying capacity of the planet. That's when people get real mad. Anyways, so I was born in 1986, so the world population was around 5 billion when I was born. And today we already passed 8 billion, so this is actually out of date. We're already above 8 billion. So in my lifetime, 3 billion humans, additional humans, this is net gain of 3 billion has happened. And the way that that looks is that, like, the city that I'm in constantly grows. Like, where are all these people coming from? I know that they're coming from somewhere, and some places have populations that are declining, but subjectively, that's what it feels like. And this is why it's difficult to wrap your head around it, because the Earth is really big. There's people all over the place. So why is it so hard for us to think exponentially? Why is it that, like, you look at this and, like, we just can't even wrap our head around 3 billion people? Like, that's just a number, right? What does 3 billion people even look like? You can't see it all in one place. It's just too much. So the reason is we evolved to think locally and geometrically, because our chimpanzee ancestors, they pick up stick, they hit thing that is bad or food, and then they eat it, right? And so their life is based on what they can see in their immediate vicinity, and maybe things that they remember, like, oh, the river is just a little further away, right? But then, like, hitting things, throwing things, running away, hiding, climbing up a tree, these are all geometric problems, right? It's something that you can interact with. It's something that's tangible. But where we live now is a global and exponential world. Like, if there's 1 million people working on AI, and they're all getting compounding returns, and another 1 million people working on better chips and they're getting compounding returns, and another 1 million people working on software and they're getting compounding returns, we cannot wrap our heads around that. We have no evolutionary history that has even primed us to think like this. And even people who practice thinking like this, it's never intuitive. So, like, a couple of dumb examples I picked for things that, like, why it's not intuitive is because you never go from 30 miles an hour to 3,000 miles an hour, right, in a car. Like, the only people who can do that are, like, fighter pilots and the people who pilot the space shuttle. Well, the space shuttle's been retired. But anyway, now they're just riding in a capsule. They're not even steering. They can't even see where they're going. They're just, you buckle in and you have G-forces, right? And then also your microwave, it doesn't go from, like, room temperature to 200 Fahrenheit to 2000 Fahrenheit, right? So unless you're like a metal worker that, where you've got a blast furnace that goes to 5,000 centigrade or whatever, like you cannot think, you have never even experienced something that is truly exponential. And so the fact that most of us never experience anything exponential means that without that experience, we cannot intuitively think exponentially. So what then people fall back on is their gut response, right? When you think about AI, it's like, oh, well, humans are special. So this is another thing. Humans love to romanticize human intelligence. Like, we're just intrinsically special. But if you go back to that model where, like, okay, what's special about the brain? It's three pounds of cholesterol and neurotransmitters. What's actually special about that? There's nothing. There's no secret sauce. There's no magic substance that makes our brain unique. It's not made of any original elements. There's no structures in the brain that are impossible to either simulate or approximate. So it's just, there's the emotional, the visceral reaction saying nothing will ever be like us, because that's a very comforting thought. There's the emotional rejection of, oh, it's nothing to worry about, because the actual possibility is it is so terrifying that you don't even want to engage with it, right? And so the combination of the emotional response and our inability to think exponentially combines to say, like, like the singularity is much closer, or whatever, however you want to call it. So if it is all exponential, then we have already crossed the Rubicon. And for those who are not history nerds, the Rubicon is a tiny little river in now Italy, where Julius Caesar took his army across, because you were technically not allowed to take your army past that. And so that was basically him, like, saying, the die is cast, I am fully committed. We are now fully committed. The genie is out of the bottle. And I remember a couple of years ago, I couldn't find this quote, but I remember seeing Elon Musk in a interview. He said things get really interesting by 2024 or 2025. And I think he was probably late. I think things get really interesting this year. I think that 2023 is the year that things get really interesting. So the short answer is, are we going to have AGI this year? I don't think so, but I don't care. Things are already interesting, and they're only going to get more interesting. So you're probably just raging, like, just tell me when, and I'm going to say that it's not a matter of when. It's not even a matter of if. It is happening now, and the choice we have to make is utopian world on the left or dystopian world on the right. And, like, we, everyone, I don't mean like you, me, every Joe or whatever. I mean billionaires, I mean politicians, I mean military leaders. Everyone has a role to play in making this choice. So how do we make this choice? Well, first, vote for politicians that are not insane and are not lunatics. Think for yourself, but more than thinking, learn. Go read, go experiment, go tinker on your own, talk to people. The social trust, social proof, and social consensus is one of the best ways to participate. I experiment. That's why I have my YouTube channel, is so that I can demonstrate these things. Propose solutions. I've written a few books on this. I've written books on the control problem, Benevolent by Design. I wrote a solution for this because, believe it or not, the problem between utopian society and dystopian society has nothing to do with technology. And it has everything to do with our philosophical disposition towards each other, but more importantly, towards ourselves. So I wrote a book called Post-Nihilism because this on the left is post-nihilism. This on the right is nihilism. And so we have to choose post-nihilism if we want that. You don't have to do anything. But in my book Post-Nihilism, I outline that choosing a philosophy is an arbitrary choice. So we could just arbitrarily choose the left one. So that's one of the solutions I've proposed. Either way, buckle up. It's happening. It's happening faster, and there's nothing we can do to stop it. Don't stick your head in the sand. Don't pretend like it's not happening. And the time to act is now. And I added a little graphic of a bad alignment take bingo, which is pretty. It's pretty cynical and pretty funny because it's like it's actually a really serious conversation. But like AGI is too far away to worry about right now. Nobody who's actually working on this stuff believes that. The only people who say AGI is, oh, it's never going to happen, it's decades away. The people who actually work on large language models and basic research, like basic science and algorithmic improvements, none of them think that. They say, oh, hey, we already have, human level performance or superhuman level performance on a broad array of tasks, and that number is going up by a factor of 100 every year. So what happens next? That's the end. I forgot to add a thank you and exit card. So that's that. The short answer is, will we ever see AGI? Maybe not. But it's happening today. It's exciting today. 2023 is the year that it changes. So get engaged. Thanks for watching.